Before we talk about messing with sinusoidal functions, I do want to point out that the period is based on going around the circle once. That's why it's like 2 pi is our default, our base period. We're going to change the speed as we go around the circle. That's how we're going to alter the period. But the period is going to be divided up into 4 quadrants. So each of the quadrants is going to be represented by 1/4 of the period. So here's at 0 period, here's at 1 period. This is going to be half the period. This first quadrant is after 1/4 of the period. The third quadrant happens at 3/4 of the period. And then the fourth quadrant, of course, happens at 1 period. The points in the sequence, top, middle going down, bottom, middle going up, and so on, those are all 1/4 period apart. So if we find out that the period is 8, then those points happen 2 units apart, 1/4 the period apart. Divide the period by 4. That's when the sequence happens. Top, middle going down, bottom, middle going up. Those will all be 1/4 of the period apart. That's why the first section ended at 1:55 and not 2 o'clock. Forgot to say that. Let's talk about messing with the graphs of sine and cosine. I like to use very technical terms, so this is called messing with sinusoidal functions. Let's first remind ourselves of what the default state is. For cosine, we have an amplitude of 1, a period of 2 pi, and it starts at the top. It goes on forever in both directions, but we're thinking that top point where we're going to think about starting. Sine, amplitude also 1, period also 2 pi, but we are going to start at the middle going up. Here's what we want to know. What happens to the graph if we perform operations either before or after the trig function? We want to think about what happens to the graph if we perform operations either before or after the trig function. That's what we want to know. We're going to start with just the operations of addition and multiplication. We're going to start with just addition and multiplication for now. But once we get an idea of what's going on, we're going to want to know if we perform other operations either before or after the function. So this brings up, what do we mean by before or after the function? This is thinking in terms of order of operations. Do we add, then do the trig function, or do we do the trig function and then add? Let's write this down in functions. Let's understand what's going on with equations and functions rather than with just words. So here is a cosine that's been modified. Here is a cosine that's been modified. It's been modified with addition and multiplication. Some of the addition and multiplication happens before cosine. Some of the addition and multiplication happens after cosine. But this is a modified cosine function. So here's a cosine modified with addition and multiplication before and after. A and B are multiplication modifications. C and D are addition modifications. So the multiplication modifications are A and B. It's A times cosine and it's B times the difference of X and C. The addition modifications are C and D. X minus C, and there's a plus D. Some of the modifications happen before the trig function, and some of the modifications happen after the trig function. Before the trig function are the modifications B and C. We take X, subtract C, then multiply by B, then do the cosine. That's B and C are before the trig function. So that's what I mean by that. And A and D happen after. After we find the cosine of all that stuff inside, we multiply by A and we add D. Those two modifications happen after the trig function. So there's addition and multiplication before and after. Each of those four constants represents one of each of the two categories. So we got addition before, addition after, multiplication before, multiplication after. I'd like to list the order of operations of things that happen to X. So what turns X into Y? First, we subtract C. Second, we multiply by B. Third, we do the cosine. Fourth, we multiply by A. And fifth, we add D. And that's how X turns into Y through this function. In this third step is where the trig function happens. B and C happen before. A and D happen after.
There are other things that we could do. I could use like a square root. I could have a square root before or a square root after. I could even square things before or square things after, but we're not worried about those right now. Let's get these four. These are the first four that we start with. Math class, sometimes questions comes up. Could it be more complicated? And the answer is kind of almost always yeah. Here's what we want to know. Here's what you're going to find out. What effect does A have on the graph? What effect does B have on the graph? What effect does C have on the graph? What effect does D have on the graph? What do A, B, C, and D, what effect do A, B, C, and D have on the graph? Presumably, if we change these values, something about the graph should change because we're looking at a different function. The different function should have a different graph. So we want to know what effects the changing A, B, C, and D have on the graph. How is the amplitude affected? How's the top, middle, and bottom affected? How's the period affected? How's the start affected? So the things that we care about are the amplitude. And that includes the top, middle, and bottom. And the period. And the start. That's what we want to know. You can start by looking at the cosine and doing some experimenting on the cosine, and then go back and experiment on the sine. But I want to know what these four constants, what do these change in these four constants? What changes can we make in our graph? Things you want to look for are the amplitude, where the top, middle, and bottom are, the horizontal stuff, the period, and where does the graph start? What happens to the start point? Normally, cosine starts at the top when x is 0. Sine starts at the middle going up when x is 0. So I should modify the start. These two starts are when x equals 0. So those are the three things you want to look at. If you change values of A, B, C, and D, what effect does that have on the graph? Amplitude, period, start. Now, a good way to look at this is to use a graphing calculator. A difficult way to look at this would be to use the graphing calculator on your graphing calculator. The best graphing calculator to use would be the one on Desmos. It's just a better graphing calculator. So here we are looking at the graphs of sine and cosine. What happens if I just do like +1? What happened to the graph? Let's turn this one off. What happens if I change this to a 2? 3. One thing that you can do is say, well, I want to see what happens with D, and then you can add a slider for the values of D and see what happens if we start changing this. So I want you to describe what D does to the graph. You want it, if it's going too much, you can change the value, say from -5 to 5. And you can change the step size. I think 0.1 is default. And then hit play again. And it could slow down a little bit. You want a little less resolution, you could put a 0.5, then it becomes a little bit choppy. This is how you find modern gamers, because it's like this frame rate is completely unacceptable. You like can't even look at it. So, oh God, it looks terrible. And if I really want to torture it, I'll bring my Atari 2600. I'm just kidding, that's not a valid threat. I don't have any way to connect my Atari 2600 to any of the equipment that we have in this room. If you want it to go smoother, then just use more steps. That's a little better. Still kind of herky-jerky. Any questions? You can actually add multiple sliders. And then turn on multiple. And just watch this as it kind of slowly bounces around. Watch carefully as the graph slowly bounces around the screen. As you watch the graph slowly make their way around the screen, I want you to feel all the tension building from the top of your head. I'm just kidding. I'm not going to bother hypnotizing you. My baseline assumption is that students don't have enough money to make it worth stealing through hypnosis. So if you turn all the lights, dim all the lights, and have more comfortable chairs, that's little from the front. Today we're going to study vertical and horizontal. And everybody's out. All right, that's going to do it for today. Figure out what these four constants, what power these four constants have on the graph of the function: amplitude, period, start. That's it for today. I will see you all on Wednesday. Everybody have a good day, and thanks for playing.